Hey guys, okay, so we're going to talk about this more in class, but this last video is on color relativity. And you guys have probably seen versions of this, but color relativity is the concept that color actually changes depending on what color it's next to. So here we've got an example, right? In the middle of this, all of these colors are the same. You can see the yellows here are the same. The blues are the same. The reds are the same. However, as you probably notice, this yellow here appears brighter next to the dark blue than it does here next to the duller green. And especially down here with the reds, this red on the left seems a lot brighter, actually even a shade or two lighter than this red here with its complement in the green. So that's just an example of how color changes. So you've got to think about that as you're putting colors next to each other. Even as you go across a painting, a yellow painting a boat on one side, when it gets across the painting to the blue of the water, at the point that the yellow touches the blue, that yellow is going to change, possibly even dull out some because it's next to its, or it's near its complement, or near a color like its complement. One of the most dramatic ways to see this is actually in this. This is kind of a famous image, and you can see these are gray and white squares, or gray and light gray squares with a green cylinder, right? So the trick is that A and B, while they look very different right here, are actually the same gray. You guys saw I just pulled that off of the A. I'm going to pull this off of the B. As you can see, it's exactly the same color. And the reason for that is because this B, this color here is next to an even darker gray, but it's also being affected by how our eye perceives the green that is near it and how our eye perceives the green that is near the light gray and then also near this gray right here. All of that changes. That color proximity changes how we perceive color. Now, we're going to talk for a second about local color. So local color is the object, is the color of an object that you see. But obviously, color changes under different lighting scenarios. So therefore, this is a pretty radical concept. Color doesn't actually exist, right? Because color only exists depending on how we perceive it under any given lighting scenario. Now, to keep our brains from exploding, we're just going to assume that strawberries are red and that they do actually exist. But right here in this illustration, in this photograph, is an example of what I'm talking about. Obviously these strawberries down here at the bottom, I'll do this every single time. They're red strawberries. They're literally the same strawberry. They're just being lit under two different conditions. And these at the bottom have a very bright red. Oops, I picked up a highlight color there. And these at the top are being lit with a cool light, a cool darker light. They're literally the same bunch of strawberries, but you can see how much their color varies between the two of them. Same thing with the greens. This green on this strawberry is, more of a neutral green. Don't want to paint the leaf. Pull that up. And the greens of the strawberries on the top are quite a bit darker, and almost a little bit cooler as well. So again, local color, you can think of an apple being red, a banana being yellow. You can look at, my cat is black, but even if he's sitting, under a window and the window paints his fur is not going to appear black. It's going to appear, a very light brown, depending on what kind of light he's sitting in. So that's just something to think about, that especially as we get into using your pieces with your different lighting sources, that the light is going to affect how your colors appear. Okay, so finally, speaking of that, there is a conventional wisdom that says in a warm light, so sunlight or an incandescent light bulb, in a warm light, the shadow that is cast is a cool shadow. Okay, and the reason for this is that as the object blocks the light spectrum, okay, so the warm light spectrum, as it blocks that, the only light that's allowed to bounce back and hit our eyes, remember from our video where we talked about subtractive color, the only light that's allowed to bounce back and hit our eyes from, this warm light coming here, hitting this, and now this is bouncing back and hitting our eyes. Because this cube has blocked the warm light, the only part of the spectrum that we see is the cool light. Therefore, the shadow is cool. And the reverse is true when it is a cool light. So when a cool light source, some of the old LED bulbs are really good at that. When a cool light source comes in and hits, an object, that object blocks all of the cool spectrum, and therefore the only light that bounces back and hits our eyes is from the warm spectrum, and therefore a cool light is going to cast a warm shadow. Now I say this is conventional wisdom because it is not a hard and fast rule, and this is a moment where I really hope I'm not the only teacher who's ever told you that you should go out and observe and paint and draw from life, because that is your greatest teacher. And I can guarantee you we could walk out of the classroom and walk around and we would find where this rule, warm light, cool shadow, is changed, because the quality of the light and what it is being cast upon will also change what the shadow looks like. And here's an example right here. So this is a picture of sunlight. Most likely it's sunset or sunrise. You can tell the light is really low on the horizon, coming through a window. So it's warm light, right? Sunlight is warm light, casting a shadow against a far wall that is also it's not a neutral color, and it's not a cool color wall, it's a warm color wall. And as you can see, the shadows that are being cast in this photograph are warm, right? I'm just going to pick up a couple of colors of the shadows here. These are obviously very warm shadows, but you can also tell by the light, the light is warm as well. And even when we get over here into the deepest part of the shadow, right? This is where a person and possibly furniture is also blocking the light coming in. While we're moving more towards the neutral side of the spectrum, this isn't really obviously warm, but it's also not really obviously cool either. And the reason for this is because, number one, this light source was incredibly warm. And number two, it's being cast against a warm surface. So in that instance, you need to look for when the rule of warm light and cool shadow and cool light and warm shadow doesn't actually match up, because it will happen. I thought of doing an assignment where I was going to challenge you guys to go out and find this and come take pictures of it and come back to me with it. But I decided not to do that assignment. However, as we get into working on your colors on your lighting plans, I'm going to challenge you to think about that, especially those of you who are using sunlight to cast to be your light source in your lighting plans. Anyway, we will talk more about this in class because I do actually want to look at it. I do want y'all to see it in real life a little bit. But this is just something that going forward, you guys need to think about how colors change when they're next to each other and how light changes color over and over and over again.